Okay, so we've defined sine and cosine of tangents. We know all the values for them. We kind of studied some identities. We'll get back to that. And then we started to solve some equations. First and foremost, you know that you can always stick the stuff in the graphing calculator. So if you have the equation, so it's like solving equations. So in the last class, I asked you like the sine of x equals 1/2. We know we looked at it. We knew by we studied that it was like pi over 6, and then 5 pi over 6. Always remember you can put this function in, sine, and then this is y equals sine of x, and then this is 1/2. Y equals 1/2. You can do intersection on your GEC to find the solutions of any equation, and whether the boundaries are from like 0 to 2 pi or 0 to 4 pi, like negative pi to negative pi. You can use the GEC to find any of these, but we're just working on analytic, doing it analytically. Like, what if we don't have a calculator? What do we do? So let's continue with day 2. Here's a bunch of another problems that we're going to do some more linears and some quadratics, and then we're going to do multi-angle. So let's just go through some examples. Example 1, 2 sine of theta equals 5 cosine of theta. Whenever you have cosine on one side and whenever you have sine on one side and cosine on the other, move the cosine to divide both sides by cosine, and divide both sides by 2, and you end up with a nice equation. Tangent of theta equals 5 over 2. You know the tangent is positive in the first and the third. Find the reference angle, and then find those two angles. It's very straightforward. So you get your calculator out. Get your calculator, and you're like 5 divided by 2, enter, and then you're going to do the inverse tangents, and you get, it's in radians. Whoops. Let's try it again. 5 divided by 2, enter, inverse tangent. I get 68.2 degrees. So the reference angle is 68.2. So I know the answers are 68.2 and 248.2. Those are the two solutions. Okay. Just remember sine, cosine, tangent. Nice. The next equation is basically, when in doubt, move everything over to the left, set equal to 0, factor, and set both parts equal to 0. So for example, this is my favorite one. Sine squared theta equals sine theta. Your first instinct is to cancel out sines, but sine could be 0, and we can't divide by 0. Same thing here. We need to make sure that cosine is not 0. So you know what? Set it equal to 0. Factor out a sine. Set both parts equal to 0. And just solve. So when sine's 0, it's 0, 180, 360. And when a sine of theta equals 1, theta also equals 90 degrees. Know how to do these in radians. So these are the answers. Very straightforward. Let's try another one like that. How about we do sine of squared is equal to sine theta cosine theta. So, excuse me, I need some water. Same idea here. We don't want to cancel anything out because it might be 0. We don't want to cancel and get. So I did divide by cosine, but I didn't get rid of it. Some people might say, well, divide both sides by sine. No. Move everything over to the left again. I'm going to abbreviate. Watch. Sine squared minus SC equals 0. Factor, once again, factor out the sine. Sine of theta equals 0. Sine of theta equals cosine of theta. By inspection, you know the answers to this. Once again, you could always put this in the graphing calculator if you have to. but let's try to do this analytically. What are our answers? Well, let's do radians this time. 0, pi, 2 pi, and then theta equals pi over 4. And where sine and cosine equal? Well, they're both positive in the first, but they're also negative in the third. So it would be 5 pi over 4. Once again, we can do this analytically. Let's try, okay, next. Well, we seem to have introduced quadratics. Let's move right into quadratics. So if I give you cosine, what is this? 2, 3. Example 4, if I take cosine squared equals 0.3. Looks a little weird, but you know what? This obviously is a calculator problem. It's obviously a calculator problem, but we can solve it. You say, okay, cosine of theta is equal to plus or minus radical 0.3. So that means that cosine of theta equals radical 0.3, or cosine of theta is equal to negative radical 0.3. Okay, as I said, it's a calculator problem, but you need to make sure whatever this reference angle is, this is in the first and the fourth. Whatever reference angle this is, it's in the second and the third. Very straightforward. Go to your graphing calculator. And do, you could do, let's see, 0.3, the square roots, right? And then you're going to do inverse cosine. For this one, the reference angle is 56.8 degrees. Now, actually, you have all the answers here because whatever the reference angle is, it's the same thing in the different answers. If you did reference angle, I think this would tell you 123.2. Let's check that out. So we do 0.3 square root negated. Let's negate that. And then we'll do the second cosine. Yeah, this one is 100. This will give you an answer of 123.2. That makes sense. This is your second quadrant, and then whatever, let's see, 180, so it would be 2. Let's see, 180 plus, that would be 236.8, and then this would be a fourth, what is it, 360? Let's see, 360 minus 56.8, 303.2. Okay, very straightforward. Last example, let's just do two quadratics. The second, if it looks like a quadratic, you deal with it like a quadratic. So for example, sine squared theta plus 3 sine theta minus 4 equals 0. So you know what? It's just like that chapter 2 or chapter 3 where you say, oh, you know what it looks like a quadratic, factor it. If it's part 1, if it's part 2, quadratic formula, or just stick it in the GDC, you say, okay, sine of theta, let's see, plus 4 minus 1. I have sine of theta equals negative 4, and sine of theta equals 1. Well, that's out, because sine of theta, the amplitude is from 1 to negative 1. What's going on here? Pi over 2. Sorry about that. Let's try another one. But how about this one? 6 cosine of theta, 6 cosine squared plus cosine of theta minus 2 equals 0. If it's part 1, excuse me, this is eventually going to be a part 2 question, but imagine the first part is part 1. So you're like, okay, I can factor this. See if you can factor it. Probably, let's see, we know it's 3 cosine theta, 2 cosine theta. Let's see, I need to get to 1, so it's going to be 4 minus 1. No, because 2 times 2 So make 4 cosine minus 3 cosine gives me my cosine. So it's a little tricky, but then you have 3 cosine theta plus 2 equals 0, and 2 cosine theta minus 1 equals 0. This one we can solve analytically. This part, we need a calculator. So obviously you can see what's going on here. There's 2 answers here, there's 1 answer here. Two here's and 2 there. Use your GDC to test the zeros out. Okay, last part. So, okay, nice. Okay, well, all these equations, all the thetas are like 0, 1. Like it's sine squared, sine squared, cosine, cosine theta. But what if I asked you, I said sine of 2 theta is equal to 1/2? Well, yeah, or anything. How about radical 2 over, let's change it to radical 2 over 2. So what's going on here? Well, let's just talk through for a second and then I'll show you a quick technique. We know that sine, this is sine, right? And you know that there's that's sine, but if it's sine 2 theta, we know that there's the period, there's 2, the 2 means there's 2 waves, 2 sine waves from 0 to 2 pi. Looks something like this. Which means if we're doing 45, we have 4 solutions here, right? So what's the technique? What are we going to do? Okay, well, as I said before, because you have the number 2 here, there's 2 cycles. 2 cycles. So what we're going to do is first replace, we're going to let b equal 2 theta, and we're going to look at the equation sine of b equals radical 2 over 2. By inspection, you say, okay, I know this one. That's 45. So b is equal to pi over 4 and 3 pi over 4. Okay, but that's the first cycle. I need to go around again, so I'm going to add 2 pi to each of those. So we're going to do pi over 4 plus 2 pi and 3 over pi over 4 plus another 2 pi, a full cycle. So b is also these solutions. Now, but that's not b. We don't want b. We want 2 theta. Therefore, theta is equal to pi over 8, 3 pi over 8. What's going on here? Well, this is equal to 9 pi over 4, so this is 9 pi over 8. And this is 11 pi over 4. So this is 11 pi over 8. And these are the 4 solutions to the equation. The sine of 2 theta is equal to radical 2 over 2. Once again, acknowledge that you have 2 cycles. Let b equal 2 theta. Quickly solve for sine of b. But then add on 2 pi to get through the new cycle. And then replace b with 2 theta. Divide everything by 2. Let's try another one with a little higher one. Let's try 3. Let's try 3 theta. Okay. Let's try the next equation. Cosine of 3 theta equals negative 1/2. Cosine of 3 theta equals negative 1/2. First, acknowledge you have 3 cycles. If you think about it, this is one way, and this is like negative 1/2 down here. But we're not looking for, those 2. We're looking for, it's like kind of like 1, 2, 3. So we have 6 solutions. We have to find them. That's fine. Let's see. So let c equal 3 theta. I'm changing the letters around. So we have the cosine of c equals negative 1/2. Once again, we're doing this analytically. So, and I'm not gonna, you're not gonna, IB's not really interested in like if they're not interested in making you grind away at the calculator. And we're going to need this more for complex analysis. So I'm just showing you this. So you say, okay, I know this. That's 60. So I know that C equals, well, the reference angle is 60 because the cosine of 60 is a half, but I'm in the second and the third quadrant. So I have 120, or, it's up to you. Let's see, we can do, 2 pi over 3, and we're in the third quadrant. What third quadrant angle has a reference angle of 60? 240, so that's 4 pi over 3. And I'm going to do it down here. Let's see what we need. Well, this is my first cycle. Let's go around again. So it's 2 pi over 3 plus 2 pi, and then I need to go around again, 2 pi over 3 plus 4 pi. It's a little tedious, but this is how we do it by hand. What's going on here? Well, 240, I need to go around again to get back to 240. 4 pi over 3 plus 2 pi, and then I have to go around again to complete my third cycle. 4 pi over 3 plus 4 pi. So, we're advanced students. Let's combine these and then divide everything by 3. So, we know this is equal to 3 theta. So, theta is equal to, let's see, 2 pi over 9, 4 pi over 9. What's going on here? 3, 8, 8 pi over 9. What's going on over here? 10 pi over 9. What's going on with my last two? Let's see. This is over 12, 14 pi over 9. What's going on down here? 16 pi over 9. Here are my 6 solutions. And then the last thing that's absolutely not showing up on the IB exam, but while we're here, and it is in the book, Cambridge Asset, I haven't seen an IB exam, but let's just cover it. Sine of 2x minus 1 equals negative 1. Obviously we know what's going on here. It's a sine wave. It's moved one to the left, one to the right, and then kind of like scrunched together. So the numbers are going to be off. It's no big deal though. Same idea. We still have 2 cycles. Let's change the sine of b. Sine of d is equal to negative 1. Immediately I see it's 270. But and I need 2 pi. So 3 pi over 2 plus 4 pi over 2, it's 7 pi over 2. But I'm not interested in d, I need that 2x minus 1. So I know that 2x minus 1 is equal to 3 pi over 2, and 2x minus 1 is equal to 7 pi over 2. And so my 2 answers, so what I have here, 2x equals 3. Sorry. So we have, well, what should we do first? Well, let's once again, we have 2 pi equals 3 pi minus 2 minus 2. So we have x equals 3 pi over 2 minus 4. What's going on over here? 2x equals 7 pi minus 2 over 2. Final answer, x equals 7 pi minus 2 over 4. These are the 2 solutions. Once again, it seems a little weird. You can always plug this in the calculator, but this is the technique for solving this. Once again, replace the term with a single letter, but acknowledge the number of cycles. Find the solutions as if it was just a basic 0 through 270, and then go through the number of cycles. If you have 3 cycles, you have the first set, the second set, the third set. Same idea here, and that's basically it. Good luck.